Hello and welcome back to another video. In this problem, we're asked to explain what it means to say that the limit as x approaches 1 from the left of f of x equals 3 and the limit as x approaches 1 from the right of f of x equals 7. So the way I actually had to say them out in terms of explaining this problem is probably going to give you a hint as to what they mean. If we're taking the value of f of x and we bring the value of x really close to 1, right? So if we're looking at the number line, right? As we go really, really close to 1, our value of f of x is going to approach 3. This minus sign means we're going at it from the left, right? So we're going like 0.9, right? 0.99, 0.999, and so on. As we keep going closer and closer, the value of f, as we go quote-unquote infinitely close to 1, is going to be 3. This is the exact same thing, except it's saying as we go to 1 from the right, right? So 1.01, right? Values that are very close to 1, just a little bit bigger, right? So it's coming from the right. When we have these x values, the value of f is 7. So in summary, as we approach 1 from the left and right, the value of the function taking on those values is approaching 3 from the left and 7 from the right. And we're asked, in this situation, is it possible that the limit as x approaches 1 of f of x exists? No. This limit is basically saying that there is a certain value where, as we take values of x close to 1, we're going to get a single value. And we can see that that's not true. If we're coming from one direction, it's going to equal 3. If we're coming from another direction, it's going to equal 7. So there's not a common value if you're coming from both directions, which is what the limit actually means. If you want a visual representation of this, right? 1, 2, 3, 4, 5, 6, 7. As we come from the left, our function approaches 3. As we come from the right, our function approaches 7. And there's no limit as to where they approach at this value in total because they're coming to different points.